Let's go. 2.3. We're going to get into the trig equations. Uh, yeah, this is big. This is big. 20% of your next test, maybe a little bit more actually. And 20% of your final will be just on this. There's my kitty. She agrees. Let's go. So this is not necessarily how I'm going to ask you the question, but it's a good lead in. We're going to find every single answer to this question. Stop disagreeing with me, Mia. So we're going to find all of them. Typically, I'm just going to ask you to find it between 0 and 2 pi. But in this case, we will do a little different. Hopefully she shuts up over. I'll start this thing over. So there we have a graph down here, and it says we want to find all the x values such that cosine of x is equal to a half, and I have cosine of x graphed right down below. Well, we want to know where the output is a half, but let's just start with this and let you know, like, hey, x, that's the angle, dude. That's the angle. This is the ratio, or the y value. So a half is about here. It's about there, right? It's about there, and if I take my little trusty ruler out and I do one of these, like, let's just say that that's right where y equals a half. This is where y equals a half, huh? But we can see we would hit a point here. We'd hit a point here. We'd hit a point right there. And we'd hit a point right there. And if you were to keep going, there's infinitely many places. There's infinitely many places such that cosine of x is equal to a half. So we're going to go do a general thing. This is a general. We want to start by looking at this and just finding its dang reference angle. We're like, dude, what's the reference angle? What angle for x? What angle for x is going to make this equal a half? Now, you could hit this thing with an inverse and go cosine inverse on both sides and say x is equal to cosine inverse of 1/2. But I would just hope you would be like, dude, it's pi over 3. Cosine of pi over 3 equals a half, because I've been asking you all to get that stuff all memorized up so we can play this game where the calculator doesn't typically help out all that much, a little bit, if you have a good foundation of what's happening. But there it is. There's our pi over 3. You can see it's a solution. It's right there. That's one of the answers. But there's infinitely many of them. Now, is there another one in between 0 and 2 pi? Anywhere between 0 and 2 pi that cosine of x equals a half. All students take calculus. So isn't cosine positive, negative, negative, positive? And our output here, 1/2, is positive. So we hit screw you for second and third quadrant. That's where it's negative. We already found our reference angle that's sitting right here where everything is positive. We just need to go find our other angle that's down here that has the same reference angle. I wonder what it could possibly be. It's 5 pi over 3. So we've now found two different angles. We found our reference angle first, just to kind of figure out what's going on. So we can say, here we are. Here's some answers. X is equal to pi over 3. There's an answer. X is equal to that angle in the fourth quadrant that has the same reference angle, pi over 3. That's 5 pi over 3. But we got a little extra piece that's happening here. Doesn't sine and cosine repeat every 2 pi? So if you were to add 2 pi to pi over 3, you'd also get another answer. So let me write that in there. So plus 2 pi. But you know what? If I added another 2 pi, I'd get another answer. What if I subtracted 2 pi? Wouldn't I get an answer if I went back the other way? Doesn't sine and cosine repeat every frickin' 2 pi? Abso-friggin-lutely. And now I'm going to put something in here. I usually write K, but your textbook uses N. It bothers the shit out of me, but whatever. So we're going to call it 2 pi n, where n is an element of the integers. integers, -1, -2, 0, 1, 3, 4, whole numbers, positive and negative, saying we can go backwards or forwards. Right, so we could go backwards, right? See, if we were to go from 5 pi over 3, and let's say we were to go back 2 pi, go back the other direction by 2 pi, we'd get another answer of negative pi over 3. We'd get that one that's negative pi over 3 by taking away a 2 pi. So this one works in the same freaking manner. Plus 2 pi times some sort of number that's an integer. So this would be our general solution. That's the general solution. That is every single freaking answer. It's taking into account that sines and cosines repeat every 2 pi. That's the period of those functions. Only tangent and cotangent have a period of pi that differ. Typically, I'm going to ask you just to find all the answers in between 0 and 2 pi. And I won't have you write like this, but you need to be able to read this, and you'll have to do at least a problem with writing it down like this. So there's a lot of variety in these types of problems, and this is the challenging along with 2.2. If you have a firm foundation in 2.2 and 2.3, I promise you good things for this entire course. So put your effort, put in 1.7 is a beast too. This whole section's a freaking beast. But once we get through 2.3, 2.4, and 2.5 are all downhill. Not to say they're easy or simple, yet if you can grind through this, identities, and your inverse, I don't think 2.4 and 2.5 are all that bad in comparison. So keep grinding, put in that work, and I will see you in the next one.